In this video, we will prove using given vertices a specific shape. Using what we know about that shape, we will write down criteria to follow when trying to prove it. Shown are two equations that will be used throughout the video to prove the certain shape. After mathematically proving each shape, I will draw a graph using the given coordinates to show the asked for shape. On the screen, you will notice the equation from earlier for slope and distance. These will be left there for reference. For question 1, we will prove that shape ABC is a scalene triangle. We know that in order for it to be a scalene triangle, it must have three unequal sides. So we will use the distance equation for each line to determine, obviously, the distance between 2 points. This will tell us whether or not the triangles are scalene. The math is given and the ending results show 3 unequal sides. We'll now graph it. First, we will draw line AB in purple, then line BC in red, and finally line CA in yellow, showing our scalene triangle. Moving on to problem 2, to prove that shape ABCD is a square. We know that a square has to have 4 equal sides and 2 pairs of parallel lines. These parallel lines also cross each other perpendicularly. We will start with proving the equally distant sides using distance equations and given coordinates. As you can see, we have 4 equally distant sides of a quadrilateral. To find whether or not two lines are parallel, based on the linear equations, you need to look at the slope of the line. If 2 lines have equivalent slopes, the lines are parallel. If the shapes are negative reciprocals, such as 1/2 and -2, then the lines are perpendicular. Using the slope formula y2 minus y1 over x2 minus x1, we can easily find the slope between any 2 given coordinates. We can observe that line AB and line CD are parallel, as well as line BC and line DA are parallel. We can also see that lines AB and BC are perpendicular because of their negative reciprocal slopes, as well as lines CD and DA, etc. Now that we have mathematically proven shape ABCD is a square, I will draw it on a graph. First, line AB, then line BC, line CD, and finally line DA. It appears that the shape is a square, thus supporting our statement. On to problem 3. Prove ABCD is a rhombus. Similar to a square, the only difference being that a rhombus does not have to have perpendicular lines. It can, but then the shape would be further classified into a square. Like the fact that a square is always a rectangle, but a rectangle is not always a square, the same goes for the rhombus. So we use our distance equation with our given coordinates and solve the expression, ending with 4 equal sides. Now we only need 2 pairs of lines. We have the slope formula for all 4 lines, solving for the slope, and we can see that lines AB and lines CD are parallel, and BC and lines DA are also parallel. What we may have also noticed is that none of these lines are perpendicular, which is completely okay because we want a rhombus that doesn't have to be a square. To show a rhombus for you, first line AB, line CD, and continuing on. There you go, our rhombus mathematically proven using algebraic formulas to be the rhombus. I hope the video helped with any questions you may have had on the subject. Have a nice day and thanks for watching.